Finally, I'd like to explain a little bit about isotopes in cave stalagmites and what they might tell us about past climates. So here are some stalagmites that have been cut and polished, and you can see what they look like in section. Normally, if I was with you in person, I would actually have the actual samples and you could pick these up and touch and feel them and examine them yourselves. So what you need to know is at the top of the stalagmites is here, and they go up through time from the bottom to the top, so they're going up in that direction through time. And they're all orientated the same way, so they're all going in the same direction. And if we turn them around, you would see the unpolished surface, and that would be the surface you would see if you're walking through a cave, if you're going through Jenolan, one of the tourist caves here in New South Wales. You'll see that each one of these stalagmites is growing at a different speed. So we've made some analyses in these samples. These are actual research samples we've worked on, and the sample on the left from bottom to top has taken 500 years, and that's about 20 centimeters tall. Whereas the sample second from right is the same height, but has taken 10,000 years to grow. On the right-hand side, we have another fast-growing sample growing over 500 years. And we extract the isotopes from these samples, and you can see in some of these samples where we've actually milled them out. So here you can see they've been drilled out. So we can get a record of the isotope changes through time. And the same on this sample, you can see lots of holes going up through here, and that's where we've drilled out the isotopes from these samples. Stalagmites in caves are made of calcium carbonate, so it's going to be a similar analysis to the ones we use for foraminifera and ocean corals. We're going to be looking at the oxygen isotopes, and it's going to be the oxygen isotopes in the calcium carbonate. And so the question then is, where does the oxygen isotope that's preserved in a stalagmite calcium carbonate come from? Well, it comes from the drip water that's dripping onto it and forming the stalagmite. And so this is the stalagmite's view of the world. And the water is coming through from the rain originally, through the soil, and through the bedrock into the cave. And the isotopic composition of this water that can get preserved in the stalagmite. And to do that, the water has to have spent enough time in contact with the rock, which is a limestone, to dissolve some of that limestone away. So the water dissolves the limestone, and then when it comes back into the cave, it actually reprecipitates that limestone in the form of calcium carbonate or stalagmite. And some of the oxygen in that carbonate has come from this water that's dripping onto it. So this is a famous example of a climate record taken from a stalagmite. It's come from China and from the Asian monsoon region. And the monsoon rains are formed when there's a big temperature difference between the ocean and the land. And the monsoons are stronger, therefore in warmer climates. The stalagmite itself, the isotopes in the stalagmites don't tell you directly the temperature. What they tell you is something about how much rainfall has fallen above the cave, and sometimes where that rain has come from. So in this record, we now have the stalagmite record in green in the top graph, and time goes from left is modern, bottom left-hand corner is today, 0,000 years before present, and this record goes back about 650,000 years. So it's a long record, as good as the ice cores, but not as long as the ocean cores. And you can see the isotope record in green varies from the modern period here back into the last ice age, in and out into warm and cold cycles. And the green line matches the red or magenta coloured line, which is the record of insolation, the amount of sunlight reaching the Earth, which is due to changes in the Earth's orbit relative to the Sun. And so what this record shows us for the first time is that the strength of the monsoon climate in Asia varies at the same time as the strength of the solar forcing, the amount of insolation reaching the Earth's surface at that latitude. So that's an important finding that wasn't known beforehand, because we can't find evidence of the monsoons from ice cores, because they're at the North Pole and South Pole, and we can't find it from the ocean sediments because they're not close enough to the monsoon regions. So why do people use stalagmites to record past climates? One of the main reasons is that they can be very precisely dated. So you know exactly where you are in the past, and you can work out how fast and exactly when climate change occurred. So in this example, again, it's from the Chinese monsoon region, and again, it's a stalagmite record. We can see an isotope composition record here going from 132,000 years ago on the right-hand side, heading towards 127,000 years ago, and that's a period from an ice age into a warm period. And you can see there's a very rapid change in the isotopes from here to here. So we have a large decrease in isotopic composition to a more negative value, so it's a wetter monsoon period. And this change occurs between these locations where the age of the stalagmite has been precisely determined. And this is by a technique which measures the amount of uranium and thorium in the stalagmite and uses the known decay of uranium to thorium. It's a natural radioactive decay process to work out the age that the stalagmite was growing. And you can see from the ages on this figure in thousands of years that this transition from a cold climate to a warm climate happened over around about 130 years. So around 3 generations. We went from a cold climate, or a colder climate, a weaker monsoon, to a warmer climate and a stronger monsoon. So this sort of evidence is important because it tells us that the Earth system can change rapidly to climate change. And if it's changed rapidly to climate forcing in the past, which is a natural forcing, can the same thing happen again in the future with anthropogenic forcing and climate change? And stalagmites are key to this evidence because of this dating. And now finally, there's a chance to look at the advantages and disadvantages of cave stalagmite isotope records compared to those that you might obtain from ocean cores and from ice cores in order to obtain records of past climate.